Welcome back to my channel. Today we're going to be talking about derivatives in context, and we'll get into some straight line motion. So the last two units we've been talking about derivatives and solving derivatives based off of just given a function, find the derivative. Now what we need to look at is what does that mean in context to other things. So if we were given a graph of f of x, and we have a tangent line through the point 1, 0. It's known that f prime of 1 is equal to 3. Interpret the meaning of the statement f prime of 1 equals 3. So f prime of 1, the big thing that we need to remind ourselves is that derivative is slope. So we know that the slope at x equals 1 is equal to 3. Without more information than what's on here, like any context involved, we can't really take out anything more than that. We just know that this is what represents as our slope. So we're going to be talking about things in context. And with context becomes units. So we need to kind of talk about units. A lot of the times when we are talking about rates or derivatives, they are talking about the rate over an amount of time. Or a unit of x. So derivatives are rates, so the rate of something. It could be instantaneous, so at a specific time, t equals, and we can kind of look at things in context of units, so whatever our units in y are over the units of x. The big thing is we're just looking at slopes, so looking at those different things and how, as they occur, looking at the context of a problem becomes easier once we can identify units of x and y. So the height of a sunflower in inches is measured over the course of 7 weeks. Use the table above to estimate h prime of 2. So first thing that we want to do is we want to estimate the slope at 2. So in order to do that, we're going to look at the slope between 1 and 3. Because we have a table, we can't really do much more than that. So h prime of 2 is approximately h of 3 minus h of 1 over 3 minus 1. So we have 25 minus 7 over 3 minus 1. 25 minus 7 is 18. 3 minus 1 is 2. So we have 9. So the slope is about 9 at week 2. So t is in weeks, h of t is in inches. So we're looking at this being inches over weeks. So at week 2, the growth of this sunflower, or the height of the sunflower, is increasing, because it's a positive number, by 9 inches per week. The number of cars that enter the parking lot of a grocery store t hours after it opens is changing at a rate modeled by the function c prime of t, where c prime of t is measured in cars per hour. Use the table to approximate c double prime per t. So c double prime of 6. So we're going to do something very similar. This time it is c prime of t, so we're going to just literally do the same thing, except for we have a little bit different notation. So we're looking between 5 and 7. So c double prime of 6 is approximately c prime of 7 minus c prime of 5 divided by 7 minus 5. We have 54 minus 92 over 2. 54 minus 92 is negative 38 over 2. Negative 38 over 2 is negative 19. Okay, so now we need to think about what our units are. C prime of t is cars per hour. T is hours, so this would be cars per hour over hours. So the rate at which the cars are entering the parking lot is decreasing at a rate of 19 cars per hour. So when we're kind of interpreting these different things, what we're kind of doing is taking the context from the problem, looking at both units, and kind of adding in what our problem would want to know about, what we're kind of looking for. So when we look at this one, interpret the meaning of your answer in context from number 1. What we are saying is the height of the sunflower is increasing at a rate of 9 inches per week at t equals 2. Oh, that 9 looks awful. 9 inches per week at t equals 2 weeks. We are not going to be doing too many of these problems where it is just straight up write the interpretation, but it is going to be useful for us when we need to look at straight line motion or later on when we're looking at related rates.